Did you get for the measure of angle 1, Owen?
So measure of angle 1.
Yeah?
I got
68?
Yeah.
So it could be 68 to 70 degrees roughly, depending on how you had your protractor. How about angle 2? Karma, what'd you get for angle 2? 110. So you probably got close to 70 on angle 1. Okay. So angle 3 should be the same measure of angle as angle 1, right? 2 should be the same as 4. How about angle 6? What'd you get for angle 6, Carly?
Angle 6. So it's the pattern. So it would be, the other one was 110, and it would be 70.
Did you measure?
Yes.
They did. We had only 2 angle measures, right? For all of these, but 6 should have been 110. Yeah, because it was the bigger one of the 2. So we have a lot of patterns showing up here. 2 and 4 are vertical angles, so they'll be equal, right? 1 and 3 are vertical. 3 and 4 are linear pairs. Or linear pair, meaning they should add up to 180. 2 and 3 are linear pairs. So we have a bunch of linear pairs, a bunch of vertical angles. We just need to connect the 2 sets of angles. 1, 2, 3, and 4 with 5, 6, 7, and 8. Notice that these marks right here show that those 2 lines are parallel. So we wrote on that page, we wrote the symbols G is parallel to J on the top so that we would remember that they're parallel. Okay, so let's talk about what type of angle we have. We have corresponding angles, correct? All right, so Taylor, can you give me a pair of corresponding angles from this diagram? You remember corresponding? No, who remembers corresponding? Coulter.
1 and 5.
1 and 5 would be an example of corresponding, right? They're on the same side of the transversal and on the same side of the intersecting line. So 1 and 5 would be corresponding. What do you know about the measures of 1 and 5? What do you notice?
1 is 70, 5 is 70.
They're equal, correct? Another pair of corresponding angles. Who can do that for me? Another pair of corresponding angles. Karma? 2 and 6. What do you notice about their measures? They're the same, okay. Another pair of corresponding, Mackenzie. 4 and 8. And what do you notice about their measures? They're equal, right? Okay, so that leads us to some of the postulates or theorems that we're going to have in today's lesson. I don't want to go there. So on the back of this sheet of paper, I want you to write so put this corresponding angles theorem in your notes on the back side of that sheet that you measured your angles. Okay, so if in order for those corresponding angles to be equal, the lines have to be parallel. It can't just be
Could I have your attention, please?
It can't just be any 2 lines cut by a transversal. Those lines have to be parallel in order for us to have equal corresponding angles. So if we knew the measure of one angle, like angle 2 in this case, we will know how to find angle 6, and then a whole bunch of other angles as well. But 2 and 6 are corresponding. Because these lines are parallel, then they'll be equal. Okay, who can recall what same side interior angles are? Let me go back to our picture. Right here, same side. What would be a pair of same side interior angles? Tessa.
4 and 5.
4 and 5, and then the other pair, 3 and 6. Okay, what did you notice about 4 and 5? Their measures. What can we conclude about? Notice the measures of 4 and 5 and the measures of 3 and 6 that you got on your paper. Can you draw a conclusion about what you got? So what did you say 4 was? 4 was around 110 and 5 was about 70? Okay. What's 110 plus 70? 180. How about angle 3? What'd you get for angle 3? 70-ish. Angle 6 around 110. What is 70 plus 110? 180. So same side interior angles we could say are what? Well, their sums will be equal, but what are their sums going to be always?
The same.
The same, which is 180, which makes them what type of angle? Starts with an S.
Symmetric?
They're linear. No, they're not. Straight angle is just one angle. These are two angles we're putting together. Supplementary. Remember, if two angles have a sum of 180, then they are supplementary. So that leads us to a postulate about same side interior angles. So please put this postulate in your notes on the back of that sheet below. And yeah, alternate interior angles. One pair would be, you said 4 and 6. The other pair would be 3 and 5. Okay, so what did you notice about the measures of 4 and 6 from your measurements? They were equal, right? And 3 and 5 were equal as well to each other. So that leads us to a final theorem about parallel lines cut by a transversal, and that is the alternate interior angles theorem. If two parallel lines are cut by a transversal, then the pairs of alternate interior angles have the same measure. So please put that in your notes on the back sheet of that paper of the angles. Whoops. Okay, so we have this figure and we're trying to find these measures. Do you have them all? Let's look at the first one. So angle 5 is 32 degrees and we're trying to find the measure of angle 1. So angle 5 right here, we're trying to find angle 1. So what type of angles are those? Are they any of the special angles that we've talked about? What type are they? Corresponding. And so we have a theorem that says corresponding angles are congruent when a transversal cuts parallel lines. So if we know one of those angles, it's going to equal the other. So on A, if 5 is 32 degrees, then angle 1 is also 32 degrees. Okay, so put that. On the second question, angle 6 is 62 degrees. And we want to know what angle 3 is. So what special type of angles, wait, let's back up here. I would want to say, here, if I was to list a reason on number 1, it would be corresponding angles. Theorem, right? And we can say theorem THM can be the theorem. Okay, so I'm writing that, but it's not showing up. All right, anyway. All right, so angle 6 is 62 degrees. We're trying to find angle 3. What types of angles are those? 6 and 3. They are what, Tessa? Same side interior. And what's the relationship of same side interior angles? What relationship do they have? Same side interior. It's a postulate, I think.
They are
Supplementary, which means what? They add up to 180. So if angle 6 is 62 degrees, we know the sum of these should be 180. We will just take 180 minus 62 to get angle 3. So that's 118. And what was the postulate we used? Same side interior angle postulate. So write that out to the side. Neater than what I am doing here, and it's a postulate. Okay, then the last one, angle 4, well, let's go. We're going to have to go a different color here. Angle 4 is 103. And we want to know angle 6. So what type of angles are 4 and 6? Special type of angles.
They're like opposite next to each other.
Something like that.
Alternate exterior.
Alternate interior angles. What is true, Audrey, about alternate interior angles? They're equal because we have a theorem, right, that tells us that. So if angle 4 is 103, then angle 6, because it's alternate interior to angle 4, it will also be 103 degrees. And our reasoning for that, or how we can prove it or justify it, would be using the alternate interior angle theorem. Okay. Let's do one more. I want you to add to this. If you had angle 2 and its measure was 83 degrees, what would be the measure of angle 5? So take a minute to figure the measure of angle 5. Okay, so angle 2, we know that measure. How are we going to get to angle 5? Coulter, what do you think? First step.
Okay, so to get to angle 5, you know that angle 2, you could just, angle 3 would be supplementary to it.
Okay.
And then you could flip over, which would also be supplementary. And then your angle 5.
Okay, so we could actually approach it a couple different ways. 2 and 3 form a linear pair, correct? So that means they're supplementary. So angle 3 would have to be 97 degrees. Is that right? And 3 and 5 are alternate interior, which means they're equal. So that means 5 is also 97. Another way to look at this would be that 2 and 4 are vertical, right? 2 and 4 are vertical, so that means they're equal. And then 4 and 5 are same side interior, so they have to be supplementary. So a lot of different ways we could look at this. Again, 1 and 2 form a linear pair, so they're supplementary. So 1 would be 97. And then 1 and 5 are corresponding, so they're equal. So a whole bunch of ways that we could go from angle 2 to angle 5, and we said it's 107 or 97, right? Okay. So for your assignment, I want you to do from your textbook just 8 problems for me.
Yeah.